Okay, we're going to look at some sex-linked traits practice problems. Again, hopefully you've watched the video and taken some notes from the video and the note slides. So hopefully these practice problems will help you have some success in the Google form questions today. So with sex-linked traits, remember, these are traits that are only held on the sex chromosomes. Remember, females, sex chromosomes are XX, males are XY. So you are actually going to include the alleles, these letters, in the Punnett squares when you're dealing with sex-linked traits, because this is where these alleles are where they're located. So let's look at, and these are not, you now have recessive traits coming back in. These are not codominant and incomplete dominant, where everything has to be a capital dominant allele. You're now going back to using recessive alleles as well. So let's look at a few examples. So if we're looking at fruit flies, an eye color in fruit flies, that is a sex-linked trait. Eye color is held on the X and Y chromosomes of fruit flies. So let's look at an example. Capital R indicates a dominant red eye color, where lowercase r is white. White is recessive. White eyes is recessive. So it says cross a white-eyed female with a red-eyed male. So white-eyed female. So females, again, XX. White eye, white is recessive, so both of her X's have to have a little r. Messing that up for you. Little r. White eye, recessive, female. Crossed with a red-eyed male. So male is X, Y. Remember, with sex-linked traits, no trait is ever held on the Y chromosome. It's just too small to carry any of those traits. So no trait will ever be attached to the Y. So for females, you'll have a letter or allele connected to each of the X's here, where males, they either have the trait or not, because it can only be represented on the X. So red-eyed male. Okay, so white-eyed female crossed with a red-eyed male. You set that up like you do any other Punnett square. White-eyed female, red-eyed male, like that. You then bring all of the letters and alleles over. X big R, X little, like that. And there are your Punnett square results. So if you're looking at this and saying, okay, what are their offspring's, potential? So you have females listed on the top here, males on the bottom. Of your females, all of your females would have red eyes, because red is dominant, and they each have one capital R. They carry, it's called a carrier, they carry the recessive trait or the recessive allele because they each have the lowercase r as well. But they would be red-eyed, dominant eye color. Your males, all of your males would have white eyes because they have that little allele, lowercase r. No chance of them having red eyes. In order for them to be red, they have to have a capital letter, in which they don't. So that's why I said they either have red eyes or they have white eyes. They can't be carriers. Only females can be carriers of a trait because they have two X's. Let's go do another one. Here it says cross a heterozygous red-eyed female with a red-eyed male. So heterozygous, one of each. So we're going to use a capital letter and a lowercase. So here's your female again, XX. She's heterozygous, crossed with a red-eyed male. Looks like that. Complete your Punnett square. Again, bringing everything over like so. And here are now your potential offspring results. So here again, you have females listed on the top. All of them would have red eyes. This one would be purebred or homozygous for red eyes because they have 2 capital letters. This one here is red eyes but carries the white eye allele. So she's a carrier for white. Where your males down here, 50% chance your males would have red eyes right here. 50% chance your males would have white eyes. So in total, 75% chance of their offspring, of any of their offspring having red eyes, 25% down here having white. Last one. If we're looking at hemophilia, hemophilia is a blood clotting disorder in which your blood does not clot properly. That is also a sex-linked trait. Example, female is a carrier. Let's use H's for this one. Female is a carrier, so she carries the trait of hemophilia, but she has normal blood clot. So capital H for the normal, lowercase is representing hemophilia, in which she is a carrier. She is crossed with a normal male. In order for him to be normal, he has to have that capital allele. You do your Punnett square. Filling them in as you go. Like so. So same thing. So if H or lowercase h represents the hemophilia disorder, only one box down here represents that. So in total, only 25% chance of their offspring having it, but of their males, 50-50 chance again. Similar to the example up here. So in summary, know that females are the only ones that can carry the recessive allele, but not have it. They can be normal, but carry the recessive allele. Where males, they're either normal or they have it. They can't be carriers. So that's why males are more likely to have sex-linked traits, because they don't have that third option of carrying it. So like color blindness is a sex-linked trait. Way more males are colorblind versus females because of that lack of being able to carry that allele on their Y chromosome. So hopefully that helps explain some sex-linked trait examples. Let your teachers know, as always, if you have questions.